let's look at an example where we're computing binomial probability distribution probabilities. So we have, to avoid unpleasant surprises when the statement comes, you try to record all your credit card transactions in a ledger. Unfortunately, you tend to neglect reporting about 5% of your purchases. Suppose that last month you had 25 purchases on your credit card account. When the statement arrives, you count the number of purchases you forgot to record. The random variable x represents the number of unrecorded purchases in a month with 25 transactions. So let's highlight first our important information we have here. So we have that we neglect recording about 5% of our purchases. We had 25 purchases on our credit card, and x represents the number of unrecorded purchases. The first thing to do is explain why this is a binomial experiment. So there's 4 criteria, so be careful here. With binomials, sometimes we're led with that prefix to think that there's 2 conditions, but remember there's 4 conditions, and one of those conditions has 2 criteria within it. So let's look at our 4 conditions here. We have a fixed number of trials. In this case, that is 25, and we represent that with the letter N. We have independent trials. In this case, that's whether we record a transaction or not, does not depend on recording another transaction. The probability of success is the same for each trial. And this is P, we represent with letter P, and that is 0.05. Right? So we neglect recording, so the unrecorded purchases. And then lastly, we have 2 outcomes of success and a failure, and this is whether we record or unrecord or not record there. So that's the way the 2 outcomes come in for a binomial. So proceeding on with the question here, we want to find and interpret the mean of x. So first, let's write out what we have so that we can compute the mean. Here, let's get back to our pen. So we have that n is 25. P is 0.05. So we have a simple formula to compute the mean here. So this is mu sub x. Okay. So that sub x there to tell us that we're working with a random variable, and our mean is n times p. So it is 25 times 0.05 here. And so we're going to compute that here. So let's pull up our graphing calculator. So we're going to type in 25 times 0.05. Our mean here is 1.25. And then we want to interpret this. So we're going to interpret our mean. So we would expect 1.25 transactions to be unreported. Okay. So now we want to compute our standard deviations. So again, another simple formula here. And again, we're going to have a subscript of x. So our sigma, right, so our population standard deviation symbol, with a subscript of x to denote that it's a random variable, and equal here the square root of n times p times 1 minus p. Extend the square root bar here. Okay, so n and p and 1 minus p. So let's type that in the calculator here and give an approximation. So we have the square root, make sure all this is under the square root, 25 times 0.05 times 1 minus 0.05. And I'm going to close parentheses again to n my square root. So this is approximately 1.09. So that's how we would compute our mean and standard deviation for our binomial probability distribution. So let's actually go through and find some probabilities. So we want to know the probability that we would record all 25 purchases. So some key things in here. So we know that n is still 25. Our probability success, which is p, is still 0.05. So we want to write out a probability statement for this. So the probability that x is, okay, we're talking about recording all 25 purchases. So we have to think about what x represents. So x represents the number of unrecorded purchases. So if we record all 25 purchases, that means we unrecord how many? Right? We failed to record how many? 0, right? In this case, x is equal to 0. At this point, we can use StatCrunch in the binomial calculator to find this. So we're going to go to Stat, Calculators, and then we're going to use binomial. So you'll notice there's two different buttons at the top. There's standard in between. So standard, you'll notice right here, there's less than or equal to. If you click on it, you have several options. So less than or equal to, greater than or equal to, less than, greater than, or equal to. So that's when you're going to use the standard calculator. And when we switch over to between, it's just when it's between two values. You'll notice you cannot change the symbols, just the numbers. So let's switch back to standard. So I'm going to fill in what n is equal to, fill in p, which is 0.05, and then change my probability statement. So in this case, the probability that x is equal to 0, and then hit compute. So you'll see that graph for us. You'll also see our probability here. So our probability here is approximately equal to, just around 4 decimal places, 2774. Okay, is that up? Let's just take a little screen capture here. You can see what we did. So we can run the binomial calculator. Our page, so let's just cut this and then paste this on the same page here. So we're just going to binomial calculator. So another problem there. There we go. So we want to know the probability exactly 4 purchases this time. So exactly 4 purchases have been unrecorded. So we're okay this time. We don't have to do anything unrecorded. And x represents the number of unrecorded purchases. So we want to look at the probability that x is equal to 4. So just like before, we're going to use our binomial calculator. We don't have to change n. We don't have to change p. Just our probability statement. So x is equal to, so we're just going to erase our 0 and put in a 4 and hit compute. And then we'll get our answer there. So I'm going to capture my screen here. Let me just move this here. exactly 4 unreported. Our probability here is equal to 0.0269. And we want to know, would it be unusual to find 4 unreported purchases, right? So we're comparing our probability to 0.05. So in this case, it would be unusual since probability that x equals 4 is less than 0.05. So now we want to find the probability that fewer than 4 purchases would have been unreported. So if we're talking about fewer than 4, 4 is not included. So this would be the probability that x is less than 4. So we're just going to go then on StatCrunch under binomial and change our symbol now from equal to less than. And then hit compute. I'm just going to capture this again so we have that as a reference. And then we're just going to move this. So our probability here is approximately 0.9659. You'll notice here on the graph, most of it is shaded, right? And these are discrete, so you'll notice they're just values plotted at 0, 1, 2, and 3. Right? So remember, it's a discrete probability distribution, so it can only take on the whole number of values, cannot take on things in between. And our last part here, the probability of at least 4 purchases. So if we're talking about at least 4, that means we want everything greater than or equal to 4. So again, we just want to go in here, and we're going to change our symbol to greater than or equal to and hit compute. So I'm just going to capture this again. And I'll put this down. So this is approximately equal to 0.034. Right? And so this can obviously have values 4, 5, 6, and 7. Remember, these are very small values. You also notice this distribution is not normal, right? So it looks like it's about skewed right. So we'll look at a few more examples.